I have a lot of hot takes. It's kind of what I'm known for. I've never been one to go along with the grain of how people are building things at any given time. I tend to like my own way of doing things. Sometimes there's overlap with how the general public does, sometimes there isn't. I find myself defending popular solutions like React as much as I find myself evangelizing less popular ones like TRPC. And as such, I have a large set of opinions that often have to change as markets shift, as the way we build changes, and everything that we do shifts as a result. And right now, we're in one of those times. AI is fundamentally changing how software is built. It's changed me and everything I do, and is starting to change a lot of the people around me and how they build as well. And it's probably starting to hit you too. But as this change happens, a lot of my opinions need to change alongside it. And I am finding that a lot of my takes that I've pushed really hard in the past have actually aged quite well. Other ones, however, less so. And it's been interesting to see where my opinions have both gotten stronger as well as have shifted entirely due to the way the whole market is changing around us. Everything from my love of React to my evangelism for full stack type safety to my deep, deep hatred of over-testing your apps is starting to shift some amount. And I want to talk about the amounts and the things and all of the opinions that I have really strongly held for a long time that are starting to get weaker as a result of how building with AI works. Do you know what else works, though? Today's sponsor.
Today's ad's a bit different because I've been using their product for years now, and I only recently learned that y'all haven't heard of them somehow. Seriously, why are any of you guys not using Railway? It's the best way to deploy servers by far right now. If you're just trying to get your GitHub repo online, look no further because I promise you, Railway is by far the best solution. Don't believe me? I'll prove it. Here's Umami. It's an open source, privacy-focused alternative to Google Analytics. Obviously, you can't just deploy this because it also needs Redis and Postgres to run. Wait, Railway hosts all of those. So there's a template that I can one-click deploy now, and it will create a new project that handles all of these parts. I click deploy, and now everything is being set up and linked together. If you have a GitHub repo you want to link to, you can do that as well, but I don't, so we're fine. And here we can see the canvas where everything is being deployed. And all of the niceties you expect from modern platforms like auto redeploy on push, quick rollbacks, super fast builds because they're doing crazy things with Nix under the hood. The founder of Railway is the first time I ever heard of Nix, fun fact. This was way back in 2021. I almost worked there, by the way. In fact, the only reason I didn't work for Railway is because the founder told me, as much as he wants me, I should probably go do my own thing. He's a really honest dude and they're a really honest company. Speaking of which, it's already done deploying. And now I have a full working Umami instance that I just deployed in under 20 seconds. And that's with everything configured. The Postgres, the val key, everything you need is just here and running that easily. If I want to add more things here, like, I don't know, another GitHub repo or another database, you just click buttons and do it, or you can configure this in your code base just as easily. From front end to back end to databases, there's no easier way to deploy, and there's also no cheaper one either, because they only charge you for what you're using. CPU that's not active doesn't cost you money. That is huge in this era with all these crazy AI workloads, and the only reason they can do it is because they're running their own servers now. They put a ton of time into making their own server warehouses. It was crazy to watch Jake as he was doing all that, and I'm so proud of them because they're killing it. Like, these rates are impossibly cheap. If you use my link, you'll get $20 of credit, and I'll be surprised if you can even hit it. Check them out now at soidev.link/railway. Let's go through my opinions that were the spiciest at the time and how they may have shifted. We'll start with a personal favorite, full stack type safety. If you're not familiar with this idea, the core of this concept is that your backend and your frontend should have a tightly knit type safe relationship such that if you make a change to the backend that wouldn't work on the front end, you immediately see that via the tools that you use to build. So if my front end expects users to have a first name and a last name, and on the backend I change it to be just name, that I would get a red squiggly line in the component on the front end that tells me the backend is returning something different. There have been lots of crazy ways this was implemented in the past, be it code gen against open API specs or GraphQL and crazy generators trying to infer types off of it. I like doing this through tools that do it for you, be it server components and the benefits there, or doing this directly with tools like Tanstack starting defining server functions, or my personal favorite at the time, which was TRPC, which would reuse the type definitions from the backend on the front end. There are lots of ways to do this, including now Convex, one of my favorite products to do full stack database backend type stuff. There's lots of things that make full stack type safety easier than ever to implement. And I think that is awesome for AI. I would say this is a take that is even better now. That right now, my feeling on this, 10 out of 10, please do it.
If you don't have full stack type safety and you're building stuff with AI, you are actively making the AI worse at building because it doesn't get feedback when the problem isn't resolved. If your agent can't run a command to see that your backend and front end don't agree, it's going to take real effort to figure out when they don't agree. One question I already got is, are there any good libraries for full stack type safety when you aren't using TypeScript on the backend? Yes, but, and the buts are important here, it will never be as good as if you have the same language on both sides, because then the LSP itself, the language server, understands the front end and back end together as one entity, and it will be much more reliable at this. The alternative, when you have different languages, will always be some form of code gen, which means that the backend code in one language has to put out a standardized spec, usually OpenAPI, that you then have a build step that will see that spec and generate type definitions as a result. You can Google search OpenAPI TypeScript code gen and find lots of different projects that make this easy. OpenAPI TS seems to be the most popular. I believe they even have a package for using it with React Query directly. So if you use all of those types of things, yeah, this will get you pretty close. That said, one of my other takes is chances are TypeScript is good enough for the backend for what you're doing. It's very rare that you actually need a different language on the backend. As such, use TypeScript on the backend if you can, especially if you need to have client code that it has to interface with. If you like Rust, you like Go, whatever, go have fun. Just know that you're making your life harder once you have to actually attach it to a real experience. And generally speaking, with AI, you should care less about the language you're using and more about the functionality that you're building. Rust is a really useful dependency when it makes sense that you want to save every single compute cycle, but chances are the compute is not the build that you're worried about nowadays. People reach to Rust way earlier than they should in general, and I would say that take is stronger than it's ever been now. So full stack type safety established, like you need a command that will tell your agent that the backend and the front end agree with each other. And if you can't do that due to the tech you're using, your tech sucks and you should feel bad. That is a take I have always had, and that is a take that has gotten stronger than ever. So next we have Tailwind is superior to CSS-in-JS. This one's funny because it was a hot take at the time, and it has since become not a hot take. Tailwind is the default that almost all of these tools use. Even companies that have competing solutions, when they make products for developers, will use Tailwind for it because it is just so convenient. Having the relationship between your styles, your logic, and your user experience all in the same file and even in the same component, because Tailwind is you just writing the styles and how it looks as part of the string definition of your component, instead of defining a class that exists in some random CSS file somewhere else and hoping that you keep track of them properly and that they have the right pieces and they're not being reused incorrectly. Very, very rough. Tailwind, by co-locating the style, the logic, and the UI, has made life much easier. And if you haven't given it a shot yet, you really should. There's a reason everybody who's moved to it never moves off. Takes a bit to get used to, and once you do, you will not miss CSS modules in the slightest bit. Next, we have server components. Oh man, I'll be real with you guys. I haven't built anything with a server component in quite a while. There are lots of things that they do really well that I do genuinely love about them. The fact that a server component lets you write backend code that does backend stuff like read from your database, and then you just return JSX, still has this magical feeling that I long for when I use tools that don't do that. Recently, I've been building mostly single-page apps using React and Vite for the front-end side. Occasionally, I'll pull in Tanstack Router or Tanstack Start when I have more complex routing, and using Convex as the backend and TypeScript for the database and everything else, and just bounce between those two things. Server components could have, and in many ways should have, been the solution to so many problems, and I do still deeply love them. But the nature of how they intermingle the backend and front end is confusing to get your head around. And a lot of people, tools, agents, platforms, and all of the things that need to support server components well, because they already support React well, a lot of those things have struggled to really deeply understand, adopt, implement, support, and evangelize server components. I think a lot of this comes down to the fact that the biggest React developers were not very big on servers in general, and you have to deeply understand React and servers and browsers to really understand the power of server components. And it comes with gotchas and compromises that aren't immediately obvious if you haven't built a deeper understanding of them. The amount you need to know to use them is too high to use them right. Where with React, you can absolutely get by with weak knowledge of React. Weak knowledge of server components means you're going to foot gun pretty hard. As such, I'd say 3 or 4 out of 10 is how I feel about that one. I don't push them much more. I don't use them much more. I don't talk about them much more. It's a lot of reasons, but yeah, you get the idea. Server components are not a thing I have really high confidence in being the future. There's a lot of things they do well and do right, but I don't think it matters to most people right now. Speaking of things that don't matter to most people right now, you should delete your company YouTube channel. I used to talk a lot more about how developers perceive things and general marketing stuff, but I realize most of you guys don't care. In fact, I can see you reaching to go double tap the side so you can skip this part. I get it. I understand. I'll keep it brief. I promise. Most people don't watch company YouTube channels. If you scroll through your watch history, you'll see that the majority of what you're watching is people talking about things, not companies creating things about what they're already making. For a company to be successful, it has to be really focused on the things it's doing, and YouTube is not one of the things it should be doing, because then you're competing with me, who is way too obsessed with YouTube, and you're going to struggle. And AI has not changed this at all. What AI has changed is the amount of money these companies have and how hard they are competing. And a lot of these companies realize marketing matters more than ever, so they're wasting more money than ever on marketing. Except for my sponsors, they're getting a really good return. YouTube at t3.gg if you're interested, by the way. Anyways, your company YouTube channel is not going to get you new users. Your company YouTube channel might help establish a deeper relationship with existing users, but that would be just as well established by embedding your YouTube videos in your docs. There are a few companies that get their YouTube channel right, and I would argue most of them are massively overspending and could spend literally 1/10 as much money paying me to talk about their thing and get way, way more as a result. So yeah, if you're not obsessed with YouTube, if it's not your lifeblood, if you wouldn't be doing it for free, you shouldn't be doing it at all. YouTube is not a place for companies to play around because nobody watches company YouTube channels. But sadly, there are more people trying than ever, which means my take is stronger than ever. Get your fucking engineers off of YouTube and get them back to work. Let me do the YouTube. What other creators do the YouTube. It's not your job. I do think being better at comms is more important than ever, and your company should know how to explain its value and pitch itself better than ever, but it shouldn't do that via YouTube videos that nobody watches. Oh boy, another one everyone's gonna hate. My defense of the browser and Electron. I am known for being a bit of a simp for Chromium, and for Electron, I find that they get way more shit than they deserve. If we look at the apps I've opened on my computer right now, Zen, Firefox-based, so not Electron, Notion, Electron-based, Helium, Chromium-based, Ghosty, native app written in Zig, not using Chromium at all, Cursor, Chromium-based, Preview, built into Mac, Finder, built into Mac, Legcord, Chromium, Electron-based. Half or more of the things I use are based in Electron, and how much I like the thing has almost no relationship to whether or not it uses Electron. There are things I love that use Electron. There's things I hate that use Electron. The harsh reality is that most things do use Electron, and many of them do it for various reasons. The cross-platform support is massive. Having good text rendering that's reliable across every platform is awesome. Having the ability to share so much code between your web app and your desktop app is awesome. The code share power is so valuable because writing code that is similar across 3 platforms and maintaining all of it is just so much work and time and money that you shouldn't be wasting. Or is it? AI's changed a lot here. It's cheaper than ever to build the native code across the different platforms. There are tools like Tori that promise to be so much more efficient with your memory. There's tons of people who are building native apps for the first time that can just kind of do it because they have these tools that will do it for them. You can even take an existing small Electron app, throw it at Claude Code, say rewrite this in Swift, and it will. So it's obviously time for us to move off the browser into Electron and towards tools like Tori at worst or native applications at best, right? Right? What if I told you I am still strong as ever on this take? First off, we need to talk about Tori. Fuck off. I am sorry, I have yet to find a useful app built in Tori. They have all sorts of chaotic issues, especially once you try to do cross-platform because they use the built-in browser engine for each OS. Tori apps are a nightmare, and the bindings for the Tori app to the native parts are even worse because you have to write them yourself in Rust. If you want to do something like, I don't know, read a file in a Tori app, you're writing that code in Rust yourself. If you want to do anything useful, you're going to be building it yourself, and you're probably going to have to deal with the differences across the native platforms. Tori, in my opinion, kills much of the benefit of a tool like Electron. And all of the legit devs I know building things on it have not been very happy with Tori. For example, OpenCode, which chat has correctly pulled out, the devs working on the OpenCode app have not been that happy with Tori so far. That's just Tory though. What about native apps? It's easier than ever to build those, right? Yeah. And it's easier than ever to have weird, obscure bugs across 3 different versions of your app that you don't want to maintain. If somebody has an issue with your app on Linux and you want to figure it out and you can't reproduce the issue on your Mac because the tech is so different and you just hope the AI figures it out for you, good fucking luck. You're going to be burning way more tokens and massively increasing the size of the context of the things that you're building, thereby lowering the quality of the outputs in a meaningful amount. Should you use AI to go build a native app for fun because you have a weird problem that you want to try out? Absolutely. But if you're trying to build good software that people will actually use, there are a lot of reasons we're using the Electron-based software every single day. There's the incredible ecosystem that handles all of the native parts alongside all of the web app parts and the bindings between those. They're often confusing and annoying, but those parts have been resolved largely with AI. There's also the fact that Chromium's rendering engine is still a work of fucking art. The things that you can do in Chromium and the power of that engine is unfucking believable. I have seen plenty of instances of somebody taking a Electron app and rewriting it in Swift UI and then having worse performance because text rendering at high throughputs in Swift is worse than it is in Electron because Google has poured hundreds of thousands of hours across thousands of the world's best engineers into optimizing every single edge inside of Chromium. A thing I feel like people forget is that, yeah, you write JavaScript to use inside of Electron, but Electron isn't JavaScript. It is one of the most complex and thoroughly tested and built C++ code bases in the fucking world. There are problems with Electron. Everybody loves to cite memory, which, to be fair, nowadays, memory is a bit more expensive. But at the same time, let's look at the programs I have open and which are using how much RAM. Oh, look at that. The most memory being used is by Zen, the Firefox-based browser. Huh. Cursor's up there, but it's only like 600 or so megs. It's below the Windows server built into my Mac. Oh, and there's Zen again with another 500 megs separate from the GPU helper that's doing 1.6 gigs. And then all of the isolated web contents for Zen. Welcome to browsers. But you'll also notice some meaningful usage from tools like Ghosty. And if we go to a more important tab, the energy usage tab, you'll see that the apps using the most energy are not what you'd expect. I did not realize Codex Bar was absolutely destroying my CPU the way it is, so we're going to kill that app right now. That would explain a lot about why my battery's been shit lately. Good to know. Spend more time in this if you're using a Mac, by the way. It's very useful. You'll notice here that Notion, which is an app I have open at all times that I use to run my channel, I run my companies through it, I spend so much time in Notion, is using significantly less power overall than even my Discord client is, or natively built apps like Whisperflow, my voice to text, or Dropbox, or Shotter. Like, the gap between these isn't very big. I did have to reboot my computer right before starting streams, so a lot of these numbers aren't accurate based on day-to-day workflows, but I promise you guys, Ghosty is regularly the most power-hungry and RAM-hungry thing in here because I'm using it to do real work. And despite the fact that it is so well-built and so efficient, when the things you're doing it are hard, it will still eat battery and it will still eat everything it has access to. Generally speaking, people are way harsher on Electron and Chrome than they should be, and I actually often find it as a good indicator of how junior and conceited a developer is. If somebody's talking mad shit on Electron, there's a 95+% chance they've never built anything useful. And there are plenty of golden examples of open source Electron-based software that fucking flies. I use Lossless Cut for chopping my assets in every single video that I publish. This is an Electron app that is effectively wrapping FFmpeg with a really complex UI to do obnoxious things with video that are automated now for me and my team. Thank you, Lossless Cut and Miffy, for making it. Not only is it a great example of a good Electron app, it is a great example of a useful tool that someone built themselves to solve problems that they have. I still think Electron is great, and most of the problems you have with it can be solved using AI. Go build things. It's useful. And if you're using bad Electron apps and that's why you hate them, I'm sorry. Company that made that app, if they can't make a good app with all of the things the browser comes with, what makes you think they can make a good app with none of them? Do you really think the same people who make shit web apps that use 10 gigs of RAM can magically get good enough at Rust to do a more performant thing? You need to be realistic here. Speaking of being realistic, type safety is free testing. A take I used to give a lot was that it felt like the tools we have for doing unit testing in the web dev world felt really, really far behind what we should have after TypeScript. A lot of the tools we use for testing in the web were built and iterated on way before TypeScript was a thing, much less a standard. I can't tell you how many tests I saw that were effectively what happens if you pass a number to this function that expects a string. Because at the time, you didn't know what you were getting on the other end. And since you never knew, you would have to test to make sure that all of your functions handled all of the things that might be thrown at them. But now we know, because if you have your function defined as only taking a string, your function only can take strings, at least as long as you are using TypeScript and checking your types. This is another one of those takes that I would say I feel stronger than ever about. If you're not taking advantage of type systems to catch when dumb mistakes happen because your agents don't have full context on your code base at all times, like if an agent is calling a function that it saw called somewhere else, but didn't pull the function itself into context, it might assume it can pass it a number when it can't. But if it then gets a type error, it knows that it can't do that, and it will learn and adjust accordingly. If you've never used an agentic development tool that has access to your type system, you haven't seen what they're capable of. It is so fucking unbelievable to see a tool write code that looks like it'll work, run your type checker, realize it has an error, and then go fix it, and not bother you at all until it finishes that. So cool. On that topic, though, we need to talk about coverage. When I first started YouTube, a very common topic people pushed a lot was this idea of 100% code cov. You have things that check how many lines of code are actually being tested and hit in your tests. And if you had a single line of code in your real code base that your tests didn't touch at some point, you're a bad engineer and you should feel bad. This is one of those takes that came from the pre-type era, where we needed ways to know our code was actually doing what we thought it would, and we would check that by checking the code through tests. That said, 100% code coverage doesn't mean everything is tested well. It just means every line of code in your code base is touched in some way by your tests. You might not be testing the right things or testing anything meaningful at all. You might just be calling the functions to make sure they return. And that's not meaningful code coverage. That is a good number in your CI. And we all love to see the check mark and the 100% and all of that, and seeing the coverage go up feels good. It's not actually useful. As chat is correctly identifying, code coverage has always been kind of a joke. You can just test the trivial case for every line and get 100% without any good testing. Not only that, test coverage can cause you problems with maintenance. If you are testing things that aren't actually the functionality, chances are you're testing implementation details that when they change will break. It is very easy to write tests that break when you make good changes and don't break when you make bad ones. In fact, most of the tests I've seen roughly fall into that. Another problem is if you have test coverage that isn't at 100% bar, it results in really weird ergonomics for developers trying to contribute. Here's a real world example I had when I was at Twitch. There was a gigantic feature that was really poorly implemented. There was a code coverage bar at Twitch of, I think it was 85%. We had this hard line set where at least 85% of code would have a test associated with it. And we had this giant feature with like 80 to 100,000 lines of code that was fundamentally broken. I rewrote the whole feature from scratch in about 2,000 lines of code, solved a ton of bugs, and here's the kicker: had 100% code cov on my changes. So I was swapping 100,000 lines of code with 90% code coverage, 100K LOC, 90% coverage, and I was swapping this with 2,000 lines of code with 100% coverage. Obvious win, right? What if I told you I couldn't deprecate that code, and that to this day, this deprecated feature is probably still sitting in the code base? Do you know why that is still sitting in the code base? Because the code base was at 85% across, I don't know, let's say 2 million lines of code. Removing 100K lines of code at 90% coverage knocks this number down, because this gigantic pile of code was over the line. If you swap that out with less code that is even further over the line, it doesn't matter, because my PR contributed 2K tested, 0K untested. But up here, we had 90K tested, 10K untested. Replacing 90,000 lines of tested code with 2,000 lines of tested code put us under the number. And to this day, this code almost certainly sits in the Twitch code base, because deleting it can't be merged. So tell me again why code coverage is good. It isn't. Code cov is a fucking disaster. The only number that ever made sense for code cov was 100, and it didn't make sense. That said, a lot of why it didn't make sense was the bullshit maintenance work and the fact that a lot of these tests weren't testing anything of meaning. The fact that most tests were written by engineers that weren't very good at writing tests made this problem way worse. And that's the only thing that's changed. If a good engineer was writing a test, they were probably not writing it very well, because it's not the thing they wanted to write. And if a bad engineer is writing a test, you know what to expect. nobody was putting much effort into their unit tests, especially when they had an arbitrary bar like code coverage to hit. Do you know who puts in the exact same amount of effort no matter what you give it? Your AI agents. This is why this takes changed a bit. I still think code coverage in general is a bad pattern, but I would knock this down to like a 6 out of 10 because a lot of the things that make it so you make bad tests are effectively eviscerated if you let the AI do all of the test writing. It's also of note that test-driven development makes more sense than it ever has too. If an agent has a thing it can run to know if it succeeded or failed at its job, that is a really good thing to go run in a loop until it succeeds. And if you can work with the agent to define those bullshit tests, cool. I already see skepticism in chat. Isn't it a terrible idea to let an AI write your tests? No. It's a much better idea than it is to let a disgruntled engineer who hates testing write your tests, or a junior engineer that doesn't understand what they're testing writing tests. The AI will do a much better job, especially if the test is there to define the relationship between the code and the expectation, and you actually read the test code to know it is testing what you care about. I don't think it's great to take an untested code base and tell an agent to go write a whole bunch of tests for you. I do think it's great to have a test be part of the plan you write with the agent that it would start and then use as a reference point as it implements the feature. Don't worry though, we have lots more to talk about with testing. First, we have mocks are overrated. There are lots of problems with mocks. You're not actually testing the things that you're writing. You're testing what you think they should be doing. You're testing your expectations more than you're testing the code itself. Maintaining them and keeping them up to date is really, really hard. And generally speaking, the ecosystem around these things and all the crazy things you have to do like dependency injection make the mocking process kind of miserable, which made them very overrated. And for a very long time, 0 of our tests had any meaningful mocks in them. That has since changed. There are lots of things that are worth mocking, that are worth defining, that are worth dealing with. And now that it's as easy as copying a type definition, pasting it to an agent, and say, make 10 mock objects that fit this pattern and shape, a lot of the things that made mocks painful are much less painful. As such, I think mocks are a little more reasonable, especially because tools like Effect make it easier to do dependency injection through services. This feels less strong. I still think they're overall kind of overrated, and this idea that you should build everything in a way where it's easy to mock, inject, and test results in you writing way more code that doesn't do a whole lot. And more code does not solve more problems always. In fact, more code often causes more problems. And there has not been a meaningful pattern in terms of how high the test coverage is relative to how much bugs exist in the code base. However, there's a pretty clear linear relationship between the size of the code base and the amount of bugs in it. So more tests means more code, more mocks means more code, and more code generally means more bugs. That still holds true no matter what the fuck's changing. But mocks have a lot of pain points that feel much less painful, so I less strongly feel my deep hatred of them. I didn't put snapshots in here. I generally used to like snapshots quite a bit because they would visualize what the thing actually did. And if you changed the snapshot in a diff, I could see what changed and understand if that makes sense. Combine that with an AI code tool, snapshots make more sense than ever. That's not in here because I forgot to put it in. I would say my takes on snapshot testing are pretty much exactly where they were before. How about manual testing, though? I've always said manual tests are underrated. Most changes should require a person to go try the thing to make sure it does what is expected. I love manual testing still, and now more than ever, especially when I'm vibe coding gigantic apps in the background while filming, I should go run those apps to make sure they do what I want them to do. Manual testing still feels essential, especially if you're letting the AI write your tests. 10 out of 10, manual test more. There are things that make manual testing more annoying than ever. Like if you're running a bunch of agents in parallel, even getting to the development environment so you can test them can be really annoying. Getting signed in when they're not on localhost 3000 anymore can be annoying. Whoever cracks the pain points that make manual testing hard to make it easier to spin up this branch of vibe-coded bullshit to see if it actually works and put me in the right state immediately, there's some good money there. I would pay for a tool that does that well. We'll see if anyone builds one. Now we're getting to the real spice. Unit tests are overrated. This take is so spicy that it's largely responsible for my success as a YouTuber. This take got the attention of a certain tech YouTuber you might have heard of who was well known for his mustache and rust at the time, who decided to bring me on for a debate where we would talk about testing and best testing practices. I think I made a good argument that we had gone way too far down the test everything side of the chart and needed to go back and rethink what tests were and weren't useful, especially in a world where everything was type safe. Not everyone agreed with me, but slowly more and more people came around to parts of my way of thinking here, which is why it hurts me to say my thinking has largely changed. Are unit tests overrated? Yes. Should they be avoided to the level I used to push? No. I'll knock this one down to a 3. A lot of the things that made unit tests painful and tedious are solved by AI. And from my experience, AI agents aren't quite as interested in writing useless unit tests as developers are. I still believe that the developers who are obsessed with testing, who make it one of the first things they talk about, who care so deeply about unit tests, are not a great source of information and generally should not be listened to. Testing people are not great, and the tests they write are often not great either. Agents don't seem to do that quite as badly thus far. The moment I see Cursor trying to write a unit test to make sure that you don't pass strings to functions that don't take strings, I will rethink what I'm doing here. But as long as you're type checking your test files, the likelihood that you're testing things that aren't type safe is relatively low. So that all said, I do find myself putting a few more unit tests in my things than I used to. It's also worth noting the tooling has gotten a lot better here. The fact that your tests can more easily be type safe is awesome. The fact that tools like vtest have made it so much easier to run said tests is awesome. The fact that AI will write all of the tedious bullshit for you is awesome. As such, unit tests are still kind of overrated. The people who talk about testing a lot still aren't my cup of tea, but I wanted to walk back my own testing takes a little bit because they have changed a little bit. Speaking of hot takes that got me into discussions with Primogen, return types in TypeScript should be avoided. Note that I said in TypeScript. If your take around return types is not TypeScript specific, I am not talking to you or about you, and your take on this being different from mine makes sense because you're not talking about the same thing I'm talking about. I'm talking about TypeScript. If return types make a lot of sense in Rust, awesome, good for you. I happen to know they probably do. In TypeScript, they have a lot of annoying gotchas, and they hide details that they shouldn't that can make them a bit of a dangerous foot gun. I felt so strongly about this that I made a video that was one of my first ever scripted videos. Before this, almost all of my videos were just me talking off the top of my head, and to this day, most of them still are. There is no scripting involved in this video beyond me at some point writing down a handful of the things I wanted to talk about. This video had me sit down and write a real thorough script, bring in guests to do their own parts, and at the end I had a highlight reel of a bunch of really deep TypeScript people confirming that they think return types don't make a lot of sense in TypeScript. This one hurts a lot. I want to be clear that my take in this previously was like 12 out of 10. If you think return types in TypeScript make sense, you're probably using them wrong and don't know about the dangers. If you don't know about the dangers, you should definitely go watch the video I just mentioned. But if you do, and the AI does as well, and you know how to keep an eye out for those things, I would knock this one down to like a 7 or so. That said, if you check my cursor rules, I do specify avoid return types when unnecessary, lean on inference. Generally, I do think this still makes sense. That said, I do also find that a lot of the AI tools we're using and the ways they pull in context can benefit from having the return type. When I don't put a return type in my code and I want to know what the type is, I hover over the function and it tells me what it returns. Agents don't have that ability. Agents just have tokens. They just have context. So the return type as a way to give the agent context on what we think this returns, that can help. I do see more use cases for return types than I used to. And as such, I'm not as offended when I see them in places where they do sometimes make sense, giving you the context within the file of what is being returned. That said, if they're breaking your inference and overriding types that should be inferred, then my tolerance of them goes down a lot. But I no longer get quite as upset as I used to, where I would literally just go in and delete all of the return types. And sometimes I would catch type errors because when you delete them, types that you were mangling incorrectly suddenly become visible. So still not something I lean into and use a lot, but I am less quick to delete them than I used to be. Speaking of things I was absurdly angry about early on, and in many ways still am, pre-commit hooks. Pre-commit hooks are a great way to tell your development team that you don't trust them. You don't trust them to use Git properly, to use it the way that they prefer to use it, and to not ship code that is broken. Pre-commit hooks are a very clear, I do not trust you implementation. Companies that add default pre-commit hooks to their projects and their applications and their source code don't trust their devs. I don't want to work at a company like that. If the company I am working at forces me to use a pre-commit hook that prevents me from committing unfinished work because I want to save the state I'm in before going off to try some other theory or something, and they're telling me that I cannot use Git the way I use it because they don't trust me to write code that is good, I will hand them my 2-week notice if I even give them that much. I hate pre-commit hooks. And the idea of making them mandatory for engineers is sickening to me. If you hate your engineers, fire them. Don't restrict them. Don't tie their hands behind their back. Unless those engineers are really, really productive and really, really cheap and don't have feelings. Psst, I'm talking about AI. If you let your agents commit, which I'm still starting to get over, it's still scary to me to let an agent touch Git. I prefer to let the agent write code and then I deal with Git after. But as I'm starting to vibe code a little bit closer to the sun, I'm allowing the agents to touch Git a little bit, and I'm finding that pre-commit hooks can be really, really useful in this regard. If a pre-commit hook is a simple type check to make sure the agents aren't committing code that has broken types in them, that can be really useful. If pre-commit hooks are making sure the tests pass before the code is committed and using those commits as effectively good states that the agent got the code base into throughout, pre-commit hook can be useful. Pre-commit hooks are a way to tell your devs you don't trust them, and it's okay to not trust AI. If you don't trust the agents to write great code, give them a pre-commit hook so they have to. That, I think, is fair. That said, I still find myself doing what this chatter suggests, which is linking Husky to /dev/null so that when you run the built-in pre-commit hooks in some repo, they just immediately pass. Don't let the agents do that, and don't tell the agents that this trick exists, because then they will go do that themselves. But if you want to block an agent from committing bad code, I suppose a pre-commit hook is reasonable. So I would say 10 out of 10 for humans, 0 out of 10 for agents. Let the agents suffer. That's their job. That's what they were built to do. And my last spicy take that may or may not have changed, how to learn a code base. This is one I've talked about a lot. One of the hardest things for earlier devs to understand is a big code base, because most of the code bases early devs have worked in are their own. They haven't worked in code bases that aren't theirs, which means they haven't worked in code bases that are large and confusing and scary. And as such, they tend to learn them wrong. They tend to learn them in this tab, the code tab. This is still the worst place to go if you want to learn a code base. I built this code base, and I don't even know where I would go to start learning how it works, because that's not a good way to learn a code base. There's a different tab here that is a much, much better way to learn a code base. And no, it's not the wiki tab, or certainly not the agents tab. It's the pull request tab. Not just the pull requests that are open, more importantly, the ones that have been merged. You can learn so much here, because the majority of code in a big code base isn't being touched a whole lot. The parts that are being touched and are changing are what's important. Memorizing the whole code base isn't going to get you anywhere. Handing the whole code base to an agent also isn't going to get you anywhere. Spending time in this tab to see what is changing, why it's changing, and most importantly, how the team thinks about those changes, and that's through the comment section, which is so valuable. That is how you learn. And if you just got a new job and you're trying to onboard to the code base, I still think this is a great way to learn. But there are other ways now too. One of these ways that I find very, very valuable, ask mode. It is so nice to be able to ask an agent, where is this thing implemented? So that you can go find it quickly. Or how does this thing work? Or where is the entry point for this endpoint? Having the ability to ask these types of questions is so powerful. It's so cool. And to watch how the agent navigates the code base when it does it is just as cool. You can learn so much about how to use the terminal, how to navigate the code base, what changes exist, why they exist, where the things that matter are, that a combination of the pull request tab and asking the code base questions through an agent like this directly can help you onboard way, way faster. I love downloading gigantic open source code bases and just prodding at them with agents. How is this implemented? Where is this implemented? How do you do this thing? Downloading the code base and reading through it yourself is nonsense. Downloading the code base and letting an agent read through it for you using its tools is so useful that my channel manager, Ben, has started building his own tool specifically for this. Better Context, aka BTCA, is a project that will download a code base and then use agents to browse it to answer your questions. If you're trying to figure out why effect isn't doing what you want it to, the agent can now browse the effect source code and figure it out. If you want to figure out how to use a specific feature, it can read the source code and the tests and all those other things to better understand it. Asking the code base is actually valuable, which is a crazy thing because that was not even viable when I was first giving this type of advice in the past. But now we have tools that are so powerful, you can ask them directly and get good answers. I still think you should spend time in this tab, but I now finally think downloading the code base can be valuable. So where would I put this take? So specifically the take was learn the code base inside of the PR tab, which I still think is true, but there are other ways that are just as beneficial that you should combine with it. So I'd put this at like a 7. Because previously I was very strict, like downloading the code base does not teach you anything. Now there are ways to learn through that, which I think is really cool. So there you have it. all of my recent hot takes and how they have recently changed as a result of AI. It's fun to go back and reflect on the things that I felt so strongly and see how when things change, they change alongside it. And I hope that you enjoyed this as well. I've never been one to hide the fact that my opinions change about things, but I like to sometimes sit and reflect with y'all to just go through them one at a time. And I hope you understand why, and maybe, just maybe, this was useful. Let me know what you think. Were all my takes dumb at the time and they're still dumb now? Or is it cool to see me change my takes as the technology around them changes too? Let me know how y'all feel. And until next time, peace nerds.